Hello, welcome to Newton's Laws and Forces, number 2, Newton's first law of 3. And so first of all, let's just learn a little bit about Isaac Newton. That's what he looked like. He was around in 1643 to 1727, which is a fair while ago. Left school at 14. Interesting. Nowadays you have to stay at school till you're 18. He left school at 14 to become a farmer, but farming wasn't his cup of tea, and so after giving it 4 years, he went straight into university, famous university in England, Cambridge, and he left Cambridge in 1665 when it closed, and it didn't close for any unusual reason other than the fact that everyone was dying from the plague, and there was a whole period around the 1665 where everyone went back to where they came from and just tried to sit out the plague, and a large percentage of the population died. Villages would set up pickets all around them and try and keep the plague out. It was a pretty tough time, but he managed to survive without catching the plague, and he then went on to develop the laws of gravity that describe the motion of the planets, and the 3 laws of motion, which we're about to describe now, and most of our equations of motion he formalised. He also invented calculus, which most students are pretty thankful for, and put forward the view that white light is made up of many colours, and when you see a rainbow, that's obviously true, isn't it? So what's Newton's first law? An object maintains its state of rest or constant velocity motion unless it is acted upon by an external unbalanced force. Let's just look at what that means. You should maybe read it a couple of times. I'll read it again. An object maintains its state of rest. That means it's stationary or constant velocity motion. So it can either be stationary or moving with a constant velocity, and it will continue to do that unless it's acted upon by a force, and that force needs to be unbalanced. If it's a balanced force, that wouldn't change its state of rest or uniform velocity. It has to be an unbalanced force. So this pretty much describes all the situations where you can identify an object is either at rest or travelling at a constant velocity. Newton's first law. So, sometimes referred to as the law of inertia, in that inertia is the tendency of an object to resist change of motion. So it's why you have to apply a force to get things to move, and if you want things to accelerate, you have to apply a force. Okay, some examples. Okay, now on the OneNote there's going to be a whole lot of videos. At rest and stays at rest. A classic example of that is what's called the tablecloth trick. That's where you have a tablecloth and you have a setting with glasses and plates and everything, and someone comes along and just pulls the tablecloth away and everything stays there, all the settings and things stay there. And so have a look on the OneNote for these videos, they'll show you, and that's a classic example of Newton's first law. It's been even done by a motorbike, where they set up a long table, lots and lots of settings, and they had a motorbike, and the motorbike zips off, pulls the tablecloth away, and looks fantastic. Another example would be the use of airbags. In this case, this is when a object is in motion and stays in motion. So when you have a collision, or imagine you're the driver, you have a collision, your body will keep moving until another force acts on it. And the whole purpose of airbags is so that you then decelerate and survive the crash. Before airbags, you'd keep moving and then you'd hit the steering wheel or the dashboard, and it wouldn't be a good result. Another way of examining that is, imagine you're standing in the aisle of a school bus, and the school bus driver slams on the brakes. So the bus stops, but because you're not holding on to anything, you keep travelling at 60 kilometres an hour or whatever until something acts on you, like a force, for example. The tendency not to change direction is also an example. So When you're running straight, if you want to turn, you actually have to apply a force to it. And so that's why it's really hard to change direction on ice or on an oily surface, because you can't apply an unbalanced force. Balanced forces equal constant velocity. What's this one? This will be just a summary, so that will also be on the OneNote. So let's look at a car. If Newton's first law is in play, all these forces should cancel each other out. And what are they? What are the forces? Well, we've got the weight force of the car. Okay, then because the car's pushing down on the Earth's pushing back, so these are the normal reaction forces at 90 degrees to the surface. You've then got the driving force of the car, so the engine, but you've got friction from the road and air resistance as well. Now, if these two vectors, this one and road friction and air resistance, are equal to the driving force, you can be travelling at a constant velocity. And that's what happens when you're just cruising along. Now, the other two, the weight force and the reaction forces, they must be balanced. Otherwise, either the car would float off into the air if they weren't balanced, or sink into the Earth. And we know that doesn't happen. So they must be balanced. So this is an example of all the forces all balancing each other out and having an application of Newton's first law. So you're going to be asked to do this question. I'll quickly mention them so you've got some time to think about them. How does Newton's first law apply in these situations? You flick your hands after washing them before using a towel. We all do it. Wash your hands and then flick into the sink. And why do we do it? If you use an umbrella and it's wet, you give it a shake before, or you might spin it before you fold it up. You can't stay upright on a bicycle without putting your feet on the ground. Well, you see some cyclists, they can do it at traffic lights, but that's because their feet are locked in, and it takes a bit of practice. People can stand on one wheel, called a monocycle, unicycle, yeah. But most of us couldn't do it. Falling off a building and accelerating is not dangerous, no. But the deceleration bit at the end is. So how is that an application of Newton's first law? And boxers get punch drunk after too many blows to their heads. If you've ever seen or heard of the boxer Muhammad Ali, he was a great boxer, very famous, and he fought a lot of heavyweight bouts, but eventually he got punch drunk and he ended up getting, so he would slur his words and he couldn't think fast. Basically he had brain damage. So how do you get brain damage from boxing, and how's that an application of Newton's first law? Now in the next video we're going to be looking at Newton's second law. See ya.